Alright, so there's a theorem which says that the opposite angles of a quadrilateral inscribed within a circle are supplementary. Supplementary meaning they add up to 180 degrees. So here's a quadrilateral inscribed within a circle. So it's a quadrilateral because it's a four-sided polygon. It's got four sides and they're straight lines and they all connect to each other. It's inscribed within a circle because the four corners or vertices of the quadrilateral are all on the circle, right? So the quadrilateral is completely within the circle, and it's touching the circle at all four vertices. Okay, so and then the opposite angles. Well, I think this is actually. Let me just draw a quadrilateral outside of a circle, um, just to illustrate what are the opposite angles. 'Cause it's easiest to see with a nice little rectangle. This angle and this angle are opposites. This angle and this angle are opposites. I don't know what these marks mean. Uh, these are all 90-degree angles. Anyway, you get the point. So angles that are not next to each other. Okay, so according to this theorem, this angle, angle A, and this angle across from it, angle C, are supplementary, meaning if you take those angle measurements and add them up, they'll equal 180 degrees. And likewise, angle D and angle B that are across from each other, those will also add up to 180 degrees. Okay, so let's use that theorem on some practice here. So if I have a situation here where I've got a quadrilateral, it's a weird one, uh, but it doesn't matter. It's got four sides. It's a quadrilateral. All four vertices are on the circle, so it's inscribed within the circle. So this theorem applies. So that gives us some good information. And we want to know what the measure of angle D is. And I don't have any information about angle B, the one that's across from it, but I do have that angle D is 2.5 times x degrees. So if I can figure out what x is, I'll be good to go. So this theorem would say that measure angle A and the measure of angle C, which is across from it, opposite to it, will add up to 180 degrees. So I know that 4x degrees plus 2x degrees is equal to 180 degrees. So I can just solve for x. 6, so combining like terms here, 6x degrees equals 180, and then divide by 6. So x is equal to 30 degrees. Now I can apply that to d. D is 2.5 times x degrees, and x is 30. So 2.5 times 30. That's 2.5 times 30. So 30 times 2 is 60, and then half of 30 is 15. So d is equal to 60 plus 15, which is 75 degrees. Which means then that this angle B has to be what? 5 degrees would make that 80, and then 100, so 105 degrees. Because by this theorem, they would have to add up to 180 degrees. All right. So yeah, let's try one more. Here's a quadrilateral. It's got four sides. It's inscribed within a circle. The question is, what is the measure of angle H? So what's this guy? So we know that, and then the angle opposite it is this one over here, angle K, 15x degrees. So we know that H plus 15x degrees is equal to 180 by this theorem. So what's x? Well, we can use the fact that these two angles are opposite each other. So 11x degrees plus 70 have to add up to 180. These are opposite angles of a quadrilateral inscribed within a circle. So I could solve for x here. 11x is equal to 110. So x is 10 degrees. Now we know that this angle h plus 15x degrees is equal to 180. So 15x, x is 10 degrees, so 15x would be 150. So h plus 150 is equal to 180. So h must be 30. 30 plus 150 is 180. 30 degrees. All right, see you later.